Hi students, welcome to this session on impulse response and convolution sum. Right, it is same as impulse response and convolution integral in a continuous time system. The same concept, but the only thing is here we are going to deal with a discrete time system. Okay, so the concept is same, everything is same. Right, in continuous time we have seen that impulse response is given by h of t, that is the response of the system for unit impulse signal, right? So if input is a del of t, what is our output is impulse response. And we come to the conclusion y of t is equal to x of t star h of t, right? Sorry, output is equal to x of t star h of t. Okay, this is what we have done in the continuous time system. Okay, CTS. In DTS, the same concept only, except t is replaced by n. So h of n is equal to t into del of n, right? And y of n we are going to get is x of n star h of n. Okay, right. Now we will deal that. As usual, in discrete time system also, impulse response is given by response of the LTI system to the unit impulse signal. Suppose when you give x of n as impulse signal, when your input is x of n, what you get in output is impulse response. When you give del of n as input, you get h of n as the output. So this is impulse response, that is output. Response of the system to the impulse signal. That's what the simplest meaning. So what happens? Simply my h of n is the impulse that is transformed. T is transformed, right? Some function, right? So we do something on this T a del of n, and what we get is h of n, right? So this is what impulse response. Right, before we have to go for a detailed analysis, we have to know one thing, like what we did in a continuous time system. Any discrete time system can be represented in terms of sum of impulses, sum of impulse signals, right? So what is that? I write this as in mathematical expression, x of n, any discrete time signal can be written as, right, sum of, right, sorry, weighted sum of, that's what, weighted sum of discrete impulse. That is what I am going to write, x of k del of n minus k, where k goes from minus infinity to plus infinity. You see where is weighted sum? This is what the weighted sum of impulse. This is sum, right? So this is any discrete time signal, right? So I can write any discrete time signal as the weighted sum of impulse. So impulse weight sum, right? That's what the meaning. Okay, how is it possible? That is the question. Okay, now we take one simple question. This I have explained in my continuous time video also. If you have any doubt, please refer that also. So let us assume this is 1, this is something, this is minus 1, right? This is 1, 2, minus 1. Let us assume this is our x of n. Let us assume this start from minus 1, 0, 1, where n. Okay, how can I write like this? This one is here, I can write this one as, it is n is equal to minus 1, right? So I can write x of minus 1 into del of n plus 1. Where del of n plus 1 will exist? Del of n plus 1 exists at only n is equal to minus 1. There its value is equal to 1. Yes or no? So if you have any doubt, please refer my video on impulse. So this signal exists at n is equal to minus 1. So it will exist at n is equal to minus 1, where the value of impulse is 1. What is x of minus 1? This is x of minus 1 means value of the signal at n is equal to minus 1. What is that? 1. So this is equal to this one only. Yes, this is n. Okay. So next, you see, I can write this as x of minus 2 into del of, sorry, x of 0. It is 0 only, no? N is equal to 0, it is there. X of 0 into del of n. What is the meaning? X of 0 is 2. Del of n is, this is existing at n is equal to 0 with value of 1. So I can write this one as x of 0 into del of n. So it will be giving the value of 2. This one I can write as x of 1 because it is n is equal to 1 here, and I can write as del of n minus 1. Why? Del of n minus 1 exists at only n is equal to plus 1. Right? At that point the value is 1 only. X of 1 is minus 1. So this will be minus. So like that. So if you add all the things, you add this plus this plus this, what you get is this 0 1. At you get this minus 1 0 1 1 2 minus 1. Yes or no? So any signal can be written in terms of, this is the weight of the signal at the particular point and its weight. So you see x of minus 1 n plus 1, x of 0 n, x of plus 1 n minus 1. So I can write anything like this. So this is the value of the signal at particular point. This is impulse. You see x of, when you substitute k is equal to 1, x1 del of n minus 1. That's what we got here. You see x1 is x1 into del of n minus 1. If you substitute k is equal to minus 1, what you get is x of minus 1 del of n plus 1. X of minus 1 del of n plus 1. So like that it will go. So that is what we know. So any signal x of n can be written as sum of weighted impulses x of k del of n minus k, where k varies from minus infinity to plus infinity. This is the first thing you have to know. This is most important concept. Okay, now we know what is our output. Y of n, output of any system. Let us take LTI system. X of n is input, y of n is output. This is LTI. So y of n is, the input is transformed into output. So t of x of n. So x of n, any signal can be written in terms of impulse. So t into summation k goes to minus infinity to plus infinity, x of k del of n minus k. Right? My system is linear. Yes or no? Since the system is linear, what happens? I can apply transform individually, but this is only a weight. This is just a number. So you cannot change the number. You have to change the signal only, because this is a signal. This is the weight. Weight is just a number. So instead of working on that, what is the thing we are going to do? So this is written as summation k goes to minus infinity to plus infinity, x of k t del of n minus k. Right? So what is the meaning? Instead of working on total signal, I am going to work with the individual impulses. Okay, that's what transforming impulse. Right? And we know that our system is time invariant system. Since the system is time invariant, we know if del of n produces h of n, or simply h of n is transformation of del of n, both are same only, right? So what will happen? H of, if input is transformed for time invariant system, input is shifted by k unit. What will happen to output? Output will also be shifted by k unit. That's what time invariant system. So here you see input is shifted by k unit. So transformation of del of n minus k is, so output will also be shifted by k unit. So k goes to minus infinity to minus plus infinity, x of k h of n minus k. This is what our output. Right? So this is the output for any signal. Right? So this you can write as y of n is equal to x of n star h of n. Okay, where x of n star h of n is summation k goes to minus infinity to plus infinity x of k h of n minus k. This is called convolution. Fine. This is convolution in the summation form. That's why it is known as summation. Right? So this is convolution sum. Whereas we have seen one thing, that is x of t star h of t. Integral varies from minus infinity to plus infinity x of tau h of t minus tau d tau. This is convolution. This is integration, so that's why it is called convolution integral. Okay, so you must know the difference between these two, right? So as usual, what I told, what is the beauty of this equation? This implies any discrete time system can be characterized by its impulse response. This I have explained in my continuous time video. Please refer that. But anyway, I simply say that if I want 10, output is y of n, x of n is, I have only 2. What I have to do? I have to multiply with 5. So I get 10. So this is what I have. This is what I want. So from what I have to get whatever I want, what is the only thing I can do? This I cannot change. This I have only. This I barely need. But this too I cannot change. What is the only thing we have to do? We have to change this impulse response. Changing the impulse response will give different output as per the requirement. If instead of plus multiplication of 5, if you 6 multiplication by 6, what you get is 12. If you put plus 5, what you get is 7. Like that. So this impulse response, changing the impulse response will give different output. As per the requirement, you design the impulse response. So whenever you want to design a system, just design impulse response only for any system. For a discrete time system, you design h of n. For continuous time system, you design h of t. This is what the significance of impulse response. I hope you understand this concept. If you have any doubt, please ask me in comment section. Thank you.